In this lesson, we're going to solve systems of equations. Now, you've been solving systems of equations since algebra, and those systems have consisted of two equations and two variables. Today, we're going to extend that to 3 by 3s, but the process is the same. So I'm going to quickly review the process of solving using addition, because that's what we're going to apply to 3 equations and 3 variables today. So here's my system. 2x plus y is equal to 1, and 3x plus 4y is equal to 14. What we're going to do is create additive inverses. I can create additive inverses for the y by just multiplying both the top equation by -4. So if I multiply the top equation, that now becomes -8x minus 4y is equal to -4, and 3x plus 4y is equal to 14. If you add them together, you get -5x is equal to 10, so x is going to be equal to -2. From here, you use what we call back substitution. I take the value for x, and I substitute it back in and find a value for y. It doesn't really matter which equation you use. I'm going to use the top equation just because y only has a coefficient of 1. So if I use 2x plus y is equal to 1, I'm going to take this -2 and replace it, put it in for the x, like that. And you get -4 plus y is equal to 1, so y is going to be equal to 5. That gives me a solution of -2, 5. That, we used to call this solve using addition. Today we're going to call this solving using back substitution, because that's really what we did. Once we added them together and found one variable, we back substituted to find the other. Okay, to solve a 3 by 3 or any system like this, we need to put it in what's called triangular form. So I want to demonstrate what that is. All right, so here we have an original system, and it's 3 equations and 3 variables. That's the kind of stuff we're going to be doing in this class. So I have 3 different equations, and what I want to do is show you. We're not going to solve this one yet. I'm going to show you what this very same system looks like after it's placed in triangular form. All right, so here's what it looks like. I still have 3 equations. You can see it's called triangular form because it kind of makes the shape of a triangle. So if we look at this, these two yield the same results. They started out looking like this. And I'm going to show you the steps eventually to put this in triangular form. But here's some characteristics. First of all, if you look, the first equation hasn't changed at all. So I have 3 variables, nothing's changed. The second equation is now down to 2 variables. And the third equation is solved for one of the variables. So if you look at this, think about how you could use back substitution once I have one of the variables to find the other 2. And what you would do is you take z, and you would substitute them in here, and find y, and then you would substitute both of them into the first one to find x. So this is an organized way of solving a system of 3 by 3 equations. Okay, before we start with an example, we need to write down some rules, some guidelines to use. And where I want to start is the fact, or I want to list some operations that yield an equivalent system. These are things I can do, like when you have an equation and you add the opposite to both sides, that yields an equivalent equation. So we're going to write down 3 things that you can do that doesn't change the meaning of the problem. So the first thing is the fact that equations can be added together. And what I mean by this is if you line up all the variables, you add the x coefficients to x coefficients, y's to y's, z's to z's, and answers to answers, and that will yield an equivalent equation. We can also multiply an equation by a constant term. That means every term on both sides of the equation, as long as you multiply every single term by the same constant, the meaning of the equation doesn't change. And finally, you can switch the places of the equations. If you have 3 equations and 3 variables and you're trying to get it into triangular form, well, it might be the case that the second equation is reduced down to 1 variable. Then you would switch places with the second and the third to get it triangular. So these are the 3 guidelines we're going to use. Again, we can add equations together. We can multiply any equation by any constant as long as it's the same constant in every term. And we can move the equations around. So we're going to work through an example using what's called, to get it in triangular form, we're going to use what's called Gaussian elimination. So that's another set of steps that we're going to write down first, and then I'm going to model with an example. All right, so we're going to write these steps down first. And the first step, these are the steps to place a system into triangular form. The first step is we're going to get rid of the x term from the second equation. So here's what this looks like. If I have a 3 by 3, then I'm just going to put in random blanks here, equals blank, and then you have that again, and you're adding stuff, whatever, and then a third one. So let's say we have a 3 by 3. My first step means I want to get rid of this guy here, okay? And to do that, I'm going to add equations together to get that variable to drop out in that equation. So that's the first step. Okay, in the second step, I'm going to eliminate the first term of the third equation. So that means I'm taking this guy out. And again, we're starting to get towards our triangular form. The first equation is going to remain unchanged. The second one is going to have 2 terms in it, and the third one eventually is just going to have a single term. So our third step is going to be eliminate the second term of the third equation. I want to take him out. Once I've done all that, my system is going to be in triangular form. I'm going to be left with a single variable and its answer. So the last step is to back substitute to solve. I already have the third variable answer, so I take him and I substitute him into that equation and find the second variable. And then I take both those answers and I substitute into the first equation to find all 3. So that's the process. I'm going to walk through one example and then we'll look at this in class. All right, here's my system I'm going to solve. It has 3 equations and 3 variables. X minus 2y plus 3z is equal to 1. X plus 2y minus z is equal to 13. And 3x plus 2y minus 5z is equal to 3. The first step was to eliminate the x term, the first term from equation 2. So I want to get rid of that x. Well, here's what I got to do. I need to create an additive inverse between this equation and the first one or the third one, but probably the first one, such that when I add these 2 equations together, they're going to add to 0. Well, look at the coefficients. They both have a coefficient of 1. Therefore, if I multiply the second equation by -1, I'm going to create some equations that I can add together. So the first equation is going to remain unchanged. X minus 2y plus 3z is equal to 1. I'm going to multiply the second equation by -1. That gives me negative x minus 2y plus z is equal to negative 13. And I'm going to add them together. X plus negative x, they're going to cancel each other. They're going to add to 0. So that one's done. Negative 2y and negative 2y is negative 4y plus 4z is equal to negative 12. So if you look at that, here's something else we can do. Every single coefficient here is divisible by 4. So I'm going to simplify this equation because you always want to simplify when you can. And I'm going to divide each term by -4 to get rid of that, to simplify my coefficients. It's going to make multiplication much easier. So here's my new system. My first equation is unchanged. X minus 2y plus 3z is equal to 1. The second equation is what I modified. It is now y minus z is equal to 3. And the third equation we haven't changed yet. 3x plus 2y minus 5z is equal to 3. So the next step is to get rid of the 3x. Well, the only equation I can use is the first one again. So if I multiply the first one by negative 3 and add it to the last equation, this x is going to drop out. Again, I can use this, modify it, add it together, and then go back to my original. So that's what I'm going to do. My first equation becomes, I'm going to multiply this guy by negative 3. I'm not going to change him in the end. I'm just going to use him and then put him back the way he was. Negative 3x plus 6y minus 9z is equal to negative 3. And then my third equation, 3x plus 2y minus 5z is equal to 3. We're not doing anything you haven't done before when you solve a system of 2 by 2s. We're just applying it to 3 equations now. So here I go. These two are going to add to 0, and I get 8y minus 14z is equal to 0. I'm going to leave that one just like it is and rewrite my system. So my original equation doesn't change. X minus 2y plus 3z is equal to 1. The second equation is y minus z is equal to 3. And my third equation is now 8y minus 14z is equal to 0. So the last step in Gaussian elimination is to get rid of this guy. Well, I have to use the second equation. And think to yourself, why? Because if I use the first equation, I'm going to add back an x, and I don't want that. So I have to use these two at this point. If I multiply this guy by negative 8, I'll be able to add them together and get rid of this 8y. So he's going to be multiplied by negative 8. That yields me negative 8y plus 8z is equal to negative 24. And I haven't changed the bottom guy. 14z is equal to 0. So he's going to end up being 18, 8 minus 14, that's negative 6z is equal to negative 24. From here I can solve for z because I can divide both terms by negative 6. And on the next page, on the next slide, I'm going to write the entire system again. So once I divided away the negative 6, here's my system in triangular form. Z is equal to 4, x minus z is equal to 3, and x minus 2y plus 3z is equal to 1. Now I'm going to back substitute. I already have that z is 4. I'm going to take that answer and substitute it in there. So I have y minus 4 is equal to 3. That means y is going to be 7. So now I take both answers, z is 4, y is 7, and we're going to substitute it in and solve for x. X minus 2 times 7 plus 3 times 4 is equal to 1. Let's see if I can do my math right. Plus 12 is equal to 1. I believe if I did that right, x minus 2 is equal to 1. And it looks like x is going to be 3. If I did it right. You should always substitute back in and make sure that everything works, just to double check your work. But in the end, we write it as a triple. X is 3, y is 7, z is 4. So we'll be doing more examples of that in class. It takes a bit, it's a bit confusing at first, but once you get it, it's really pretty easy and straightforward.